Hello, everyone. All right, so now let's talk about transformations of functions, or should I be like transformers? Anyways, no, let's not. Anyways, today I want you to be able to comprehend transformations, characteristics to visualize, describe, and demonstrate changes to parent functions. So what we're doing here is we're demonstrating all the different types of ways that you can kind of see these. Now, the next slide is going to be kind of long. I'm going to let it just all appear all at once. Y'all can pause me to make sure you copy it all down. Okay, so here's our basic formula. A, B, and C, or dang that, wrong color. A, B, C, and D are just real numbers. Now my pen's not wanting to write. A, B, C, and D are just numbers. Okay? If there is a negative in the very front, right after the equal sign, that means a reflection, which means it would go face down or like face the opposite direction. I'll talk about that more in a second. If the number in front of the parentheses, A, is bigger than 1, you have a vertical stretch, which means you somehow made this thing grow taller faster. Well, again, we'll look at all these types of transformations. If you have a number between 0 and 1, like a fraction or a decimal, then they have a vertical compression. B, I'm not going to do too much, but I am introducing you to the idea, especially for you juniors who will hopefully be taking pre-cal next year, because you're going to see that more with that. B is about horizontal stretch and compression. Like greater than 1, we horizontally compress. Between 0 and 1, we horizontally stretch. And again, I'll show you kind of what that means there. Okay, but I will focus on A, C, and D. Now C, notice it's inside the parentheses with the X. A plus tells me to go to the left, and a minus tells me to go to the right. So you kind of have to think opposite there. The B and the C, like those are in the parentheses, that's kind of what you always have to think is that they're opposite. Now on the outside we have a D, a number there. A plus means I'm going to move up, and a minus means I'm going to move it down. So what does this all mean? How does this all translate? Translate talks about something like that. Okay, so here is an example of a parent function that has gone through some transformations. This does not mean like Dr. Jekyll and Mr. Hyde type of thing. It's just that it's gone through some transformations. So, first off, what I would do is identify what family does this belong to. And obviously because of the x squared, this should belong to the quadratic family. Okay, so you kind of hopefully are already visualizing what does this graph look like. It should look like a U-shaped parabola, sir. Okay, and then identify the different types of transformations that you see. Because of the negative in the very front, that means there's a reflection. And because of the plus 3, notice that the plus 3 is not in parentheses in there with it. Technically, if I had done that, I would have done something like x plus 3 squared if I wanted inside parentheses. But I didn't. So it's here. So that would be like the next thing, which would be that it was shifted up, or it was moved up 3. So what does that mean? Well, that means that here's my normal quadratic, and this is just a rough sketch. Okay, the reflection means that it now has an upside down U, and the shift up 3 means take that point and go up 3. So like instead of being right here, I am going to go up 3, and then I can point it down. So it would look something like that. And again, these are rough sketches. We will work on the idea of how you can come up with more specific points from the calculator and stuff like that later. So what's my new domain and what's my new range? Well, the domain is still going to be negative infinity to infinity because you can see there's arrows on the left and the right, and it's just going to the left and to the right. The range, now the arrows are going down, so that means it now goes down to negative infinity with a max, it stops at positive 3, so I have that's my interval notation there. So you can kind of hopefully compare that to your notes chart about parent functions and see how that made a change. Next example. Okay, here's another example where I want to identify, again, I would always identify the family first and then go from there. So this is an absolute value function, and the minus 3 is inside the parentheses, or it's considered to be part of inside with the x, because it's inside the bars of the absolute value symbol. So that would tell me that I have a Shift -3 means I go to the right 3. You always think opposite there. You have to be opposite inside the parentheses. And then the -1 means you're going to go down. Okay? So if you look at this, normally this is a V-shaped graph. Let that play out there so you can kind of see the V-shaped graph. Okay, the right 3 means I'm going to go to the right 3, but I'm going to go down 1. So I'm going to go, you can see there, that second green dot means I went to the right 3 and down 1. So that V, that point right here where they would be V, or like making that little point corner, gets moved over to that spot at +3, -1. And so that would look like that. So that's the transformation of it like that. Now, what does that mean? The domain, again, the domain is still negative infinity, positive infinity. That didn't affect the domain, but it did affect the range. The range now starts at -1, because that's the lowest point, and goes all the way up to positive infinity. So yes, I still want you to see the domains and ranges of these as they make the transformations. Okay, so here's one that's a little bit more complicated in the sense that there's quite a few transformations. Actually, pretty much all of them, except for the b, because again, like I said, most of the time I'm going to ignore the b. So I have a square root function. The negative tells me I have a reflection. The 2 that's in the front, because that's greater than 1, tells me I have a vertical stretch by 2, and I'll explain that in a minute. And then I need to go to the left one, and then I need to go up 3. Okay, so here's my square root function, and what I'm doing here is I'm also plotting out a couple extra points. So instead of just saying 0, 0 and making a little curve that goes off to the right, I'm making note that like if I put 1 in place of x, square root of 1 is 1. So then if x was 1, my y would be 1. But then I have to go all the way to 4. See, okay, square root of 4 is 2, so my x would, if my x is 4, my y is 2. So I plotted out those points so I can make those. And the reason why I'm doing that is this. The reflection is going to make that curve go down. But the vertical stretch by 2 means I'm going to multiply each one of those points by 2. So instead of being like at 1, 2, it's now at 1, 1, 1 is now at 1, -2, because again, it's reflected. So instead of being like up here, it's down there. Okay, and then same thing with the 4. Instead of being 4, 2, it's now 4, 4, because you're multiplying literally by 2. Okay, that's kind of how that works. And I can show you all that off a table and so on. But basically what that means is stretching, it's like you're making it taller. Okay, obviously it's flipped, but it's like it's taller. If I were to draw that, it would have been something like that. And you see it's taller. But now it's being flipped over, so we're not going to actually get that right there. Okay, and then I want to go to the left one. So I'm going to take each one of these points, these green points here, right? And I'm going to move them all to the left 1. So that's what this is. You can see those orange dots. And then I'm going to move all those orange dots up 3. So 1, 2, 3, and you end up right there like that. There's your graph. There you go. Now let's look at the domain and range. The domain is now from -1 to positive infinity, and the range is from negative infinity to +3. So that's pretty much how those kind of cover. I will answer more questions about this. Keep in mind, I want y'all to be able to tell me from a function, can you tell me the family and the transformations? Or if I give you the transformations, can you come up with a function? Or can you go from this to the graph? You know, all those things are things that you'll see on the test and you're going to see on the assignment. Anyways, I want to make sure I keep this short as possible. I mean, I'm definitely can add more. If you have more questions, feel free to ask, and I will answer and put more into it when I see y'all. Anyways, that's it for today. Thank you very much for your time, and y'all take care.